So what's on your mind? Do we understand some of the procedures that we'll have throughout the year? The marking period problem, that's something that comes around every 3 weeks. It's required. It's on Google Classroom. It's also like an online event. You'll do it online. You'll submit it online. Maybe you'll take a picture of your work if you feel like that supplements what you did. Okay, so that's due Monday at midnight. So if you're like a last minute person, make sure you get it done by 11:59 and 59 seconds. Okay. What else is on your mind? So we're building towards a test on Friday. There'll be a little review tomorrow. We still have something to learn today. So you'll find that the tests are not like a big surprise. The stuff we've been learning, that's what's going to be on the test. But you'll see when you do the review that it's everything we've been learning, and you start to kind of put it together. What else is on your mind? I'm sure some of the homework, right? Let's take a look. Now, if your concerns, well, I should say, if you notice that 22, 23, 24 were kind of different, but like you noticed that and you tried them, good. Okay. If maybe you were a little unsure about something with those, that's why there's homework and we can still talk about it. I hope that you still tried them, maybe anticipating that I would check them, but whether I check it or not, keep working, keep trying. We'll go over 22. I think that is a good idea. And then we'll see what's up with maybe 23 or 24, because I want you to have a chance to maybe go back and try something with maybe some of these problems in the 20s. There's a couple ways to approach 22. Kind of like the deep down theoretical way is to just ask yourself, when does sine equal 0? When does y equal 0? Sine is y. So now we got to kind of be thinking, okay, wait, zeros. When does y equal 0? When does y equal 0? Maybe you picture the x and y axis. Well, back in the beginning of time, y equaled 0 if you were on the x-axis. If you're on the x-axis, y equals 0. Now, maybe some other pieces of this puzzle could be that you think of this as y over r, and that causes you to kind of think of it as 0 over 1. That's good stuff because that's still true. Now I can start to think, when does y equal 0? When does r equal 1? Well, that would be our beloved unit circle. There's one more thing to think about here. It's the goofy pi over 2 to 3 pi over 2, right? Do you remember it? Pi over 2 to 3 pi over 2. That's trying to focus you on a place. Now, that place could be anywhere from here to here, because that's pi over 2 to 3 pi over 2. And so now we start to focus in on one point. One point. That's where this is a little different. Are you kind of focusing on that one point? If you had to throw a dart at it, where's the bullseye? I missed. Now I hit it. Okay, what do you guys think? Y equals 0 at this point? Am I between? Yes, I'm between. Does r still equal 1? Yes, r equals 1. Okay, so now all we got to do is, I guess, well, what do we have to do? I guess we got to think about the rest of the answers. I mean, I assume that you conclude that x equals -1. We kind of get that conclusion. Again, r equals 1. It's not a triangle. Here's the little lesson. Here's kind of the extension from yesterday. It doesn't need to be a triangle. It just needs to be an X, a Y, and an R. That's what you found for every other problem, X, Y, R. It just so happens that it's a point for this problem. So what if I told you that 23 and 24 were a similar idea? I don't want to ruin all the fun, but what do you want to talk about? Let's look a little bit at number 24. Okay, undefined. So talk to us. What would have to be true about tangent? I'll get us started. Tangent's y over x, right? So what would have to be true if it's going to be undefined? Remember, ask yourself, when does x equal 0? When does x equal 0? When does x equal 0? Okay, now we kind of look a little more, okay, so where, oh, it says pi to 2 pi. Pi to 2 pi, that's the other piece of that answer, or excuse me, of the given. Here's pi to 2 pi. Okay, so we're back to a point. That point down there is when x equals 0. It's also, well, now that we know the point, we could say that y equals 1. Sometimes students aren't sure exactly what y value to choose. Okay, notice that I'm going to the unit circle when I can. We love the unit circle because it makes answers easy. So if I can go to the unit circle, then again, when I can, I will. So y equals 1, r equals 1, you're back in business. I see you nodding your head. What else are your needs or wants? Yesterday, we were given a trig value. The day before that, we were given a point. What we're going to do is feel like we're coming back to something you've seen a little bit. We're going to give an angle. All three of these problems get us to the same place. The place they get us to is a sketch of either a triangle or now, as you can see, maybe it's a point. But you're going to feel like that it's the same thing. It's just a little different given. A little different given. All right, here we are again. We got a little thinker guy. And once again, I'm asking you, what do you think? What do you know? Now, what you want to do here is focus on 60. Okay, 60 is definitely the new piece to this. It's kind of a neat time in math right now, especially for the visual learners, because if you draw a sketch, you know, you might start to figure out something else. So I'm not giving away a big surprise here by drawing 60 degrees. So what can you do with this sketch? What can you do with 60 degrees? Is it starting to become almost second nature? Is it starting to become a natural occurrence? There's lots of natural occurrences. There's the Grand Canyon. There's the Appalachian Mountains. There's a triangle. That's a pretty natural occurrence to draw that triangle. What else do you know?
It would have to be a 36-9 count.
What else do you know? Now, if you're like, Mr. Naylor, we're trying to do the sine, right? Like that's y over r, right? Okay. So any y values, any r values, any dimensions that you can match with a 30, 60, 90? Go ahead.
R would be 1, so then I make x 0.5 and y 0.5 times square root of 3.
Now, you can write this down if you want because it's right. It's very good, Brandon. But I'm sure there's a lot of people that are like, where'd that come from? Okay, but it's right. And what I want to do is I want to show you guys that we kind of have a more of a familiar way to describe what you just showed here. There's a relationship between the sides. And again, he's right, but there's a little more of a familiar way. Okay, so I don't want to take away from what you did here, but I'm going to kind of go back to the side that's the shortest. Okay, now the side that's the shortest is the side that goes with the smallest angle. And maybe you were absent that day, maybe you weren't, but we typically say that with the shortest angle is side 1, a length of 1. And so we kind of start with the number 1. Okay, now, what do you guys remember about the hypotenuse? Brandon said it correctly. The hypotenuse is related to the shortest side. The hypotenuse is always going to be double. And so we say 2. Okay, now just quite honestly, this goes back to some prior knowledge. If for some reason you don't have that knowledge, you can get it right here because this is a 1, 2, and then the side that goes with 60 is commonly or familiar or more familiar said that it's going to be root 3. So we have a 1, 2, root 3. And that was the exact same thing you said, you just kind of scaled it differently. Okay, now just wondering, do you guys realize that we have enough information to answer the question? We have y and we have r. So why not? Let's answer it. Okay, because y is root 3, r is 2. And so the sine is equal to root 3 over 2. Now, it would depend on where you're at with this whole thing. Maybe some of you are trying to just still figure out the 1, 2, root 3. And let me just remind you that in a 30, 60, 90, across from 30, the smallest angle is the smallest side. We call it 1. And then it kind of goes from there. The hypotenuse is 2. The other leg is root 3. So that's just some prior knowledge. But for this year, what about the unit circle? I'm sort of feeling a little like kind of a little bit like I feel like I'm feeling a little slighted here. It's like, where'd the unit circle go? It's been so much talk. Okay. The reality is that it's still here. You just have to understand that our triangle is kind of like outside of the unit circle. But it's okay because this point right here, this point kind of got found by scaling back these numbers, just like we did on the first day. So that point is, the y value of that point is still root 3 over 2. Okay, and I don't know, Brandon, I don't want to kind of put words in your mouth, but you had said that r equals 1, which, you know, you could do the problem with 1. I just want to say that it's easier for kids normally to do the big triangle, the triangle that goes outside of the unit circle, and we get back to that point anyway. All right, so the unit circle is still part of this problem, okay? But special triangles have now become a big part. Secant of pi over 4. Secant of pi over 4. I don't want you to get bogged down with the radian. So let me say something and then we'll let you do some thinking. Yes, I gave the angle in radians. Okay, first thing you have to understand is that pi over 4 is still just an angle. Now, if you haven't converted it yet, convert it. And you'll discover that it's the same as 45 degrees. Okay, what I want to share with you is that we will do the rest of this problem by thinking of 45 degrees, and it's okay. Because whether the problem's in radians or degrees, the answer is going to be the sides of a triangle. Okay, are you following? Because sometimes kids are like, well, I should do it in radians, right? It doesn't matter. Our goal is to find the sides of a triangle. Okay, so it's not like the answers in radians. It's not like the answers in radians. If you're saying, then why did you give it to us that way? Just to make it a little extra fun. Okay, just so as a student of trigonometry that you understand what to do if you see something like pi over 4. Okay, well, what do you know? What do you know about a situation like this? Again, that's pretty much a given at this point. So what do you know? This one's a 45, 90. So what do you know? What do you know about the sides of a 45, 90? Julia? Good. Now, some of this goes back to prior knowledge, but if the sides are going to be the same, what value would you like to give them? Pick an easy value. 1. Give me another 1. So we have a 1, 1. We have a 1, 1. Now, just saying, if there's like a time you're in Jeopardy or something and you're like, oh crap, what's the other side of a 1, 1? You can just plug in the Pythagorean theorem. Okay? Pythagorean theorem will give you the hypotenuse. But once you do that, you're going to find out that it's always root 2. Now, do you realize what's just happened here? We've done 2 problems, both that use special triangles. Okay? Yes, that's what's going on here. I'm giving you an angle, but it's always going to be an angle in a special triangle. So we have to get familiar again with these 2 special triangles. That's why I'm going over them. Cool thing is that we have enough information for secant, right? Because secant is r over x. Make sure you get to know those. By Friday would be like a really good idea because that's when the tests will be. Okay, but r is root 2, x is 1. We get root 2. What are you thinking? You guys are normally good for questions. Just what are you thinking? Okay, now just some things that are on my mind here. These are the 2 scenarios. These are the two special triangles. If you're like, what happens if you give us 50 degrees? Not going to do it, because I give you 50 degrees, you can't draw a special triangle from memory. Okay. The other thing is that these triangles could be in other places, like in negative places, kind of like yesterday. Okay. So all those things still come into play. I did another one of these things. Do what you want with it. Take a picture. Just read it. Honestly, it's probably going to be the natural thing that you do. But let's just look at it. If I give you an angle, you're going to sketch the special triangle. I didn't draw the special triangles up here on the PowerPoint. So there's the 1, 2, root 3, and then there's the 1, 1, root 2. If you want to, redraw them, because it's going to be these two triangles. Okay, if that is more helpful to you. Again, if you want to redraw the triangles, but the bottom line is we have the two special triangles with kind of the always effect going on here. Always with that arrangement of numbers and sides. Now, I'd like to do a couple more problems when you're ready that will kind of unveil just a few other, I guess we'll call them steps, but really just a few other things that you need to think about. Also, again, as I asked you, what are you guys thinking? Sometimes kids will say, what if you ask us to do tangent? Or what if you ask us, I could ask you to do any trig function. So just because I'm saying the sine of 225, it's not the sine that's most important. It's the 225. Because I could ask you to do the cosine of 225. I could ask you to do the cotangent of 225. So let's focus on 225. Let's make sure that you're getting off to the right start. And let me also make sure that everybody is thinking of the triangle the same way. And here's maybe the part where you step in. What do you think? So we've got an angle, we've got a triangle. What else is true? There's like a little new piece to this. What else is true? Go ahead, Grace.
The inside angle is.
You know what she just found? Can you use like a term from right around the first couple days of school? Call it the inside angle. It's fine. You found it. You found it correctly. What you really found was the reference angle. The reference angle. If that was almost like just second nature for you guys, awesome. That's how math's supposed to be. So we do a little bit of math. We find a special angle. Now you have a reason for why we learned that. That actually is one of the reasons, even if it seems kind of easy to you. So, so we have a 45, 45, 90? Sure. How about the sides of a 45, 45, 90? 1, 1, root 2. One, 1, root 2. I don't know if I can look at it much longer. -1? -1 root 2? Better. Okay, again, where are you guys at? Are you sure? You okay with what's happened here? Okay, because you can find the sine, you can find the cosine, you can find anything. I'm just asking for the sine just to keep it quick. So we've got y over r. Okay, now what just happened here is, whether it was instinctive or you kind of need to see it, but it's true, reference angles. Okay, you're going to use reference angles. It's the other piece to this simple diagram. All right. And so I have one other problem before we do like a couple exit questions. But let's focus on this. So we've got the cosine of 5 pi over 6. It also is to kind of help us realize something. Cosine of 5 pi over 6. Before we maybe jump into this, sometimes students will say, can you show us the wrong way, or can you show us some mistakes? Yeah, we can learn from that sometimes. This is a common student mistake. Be careful that you don't think that this is kind of like yesterday, and somehow 5 pi becomes x and 6 becomes r. Kind of like yesterday. The difference here is that 5 pi over 6 is not the trig value. It's not the answer. Rather, it's the angle. Okay, so when you see 5 pi over 6, you have to think, oh, that's really an angle. And as I said before, converting it is probably the approach. Okay, you don't need to do the problem in radians. Okay, remember, there is a shortcut to this. I hate to kind of say shortcuts, but it is true that you're just going to take 5, 6 times 180. 5, 6 times 180. That's what happens when you have a pi that cancels out. Okay, so unless you want to set up the factor label method or maybe a proportion, it's fine, and you get 150. 150. Okay, so let's not stop now. You can draw a sketch of 150, and then the fun begins. Okay, kind of the same thing we've done. There's actually not anything really new about this problem. It might be something you want to try to dabble with and see if you can get the whole thing right. Listen, I know you can do this, but it is another common mistake that just these angles get mixed up. Okay, I know you know that that's 30 on a good day. So make it a good day. That's your 30, that's your 60. Across from 30, across from the small angle is 1. And then 2 is always the hypotenuse. That makes root 3 match up with 60. 1, 2, root 3. Right? Not quite. Negative root 3, right? Negative root 3. Listen, the position of your triangle, the position of the legs, will determine positive and negative, just like yesterday. All right, so cosine is x and r. You've got negative root 3 over 2. Remember, negative root 3 over 2 is not just like some random answer. Negative root 3 over 2 is actually referring to this point on the beloved, specifically the x of that point. That's the x value. Okay. You might feel like you start to see some of the same answers. Yeah, that's because if you go around the circle enough, you're going to start to recognize the points that you get at. Okay. So yes, you're going to start to have some of the same answers. Oh, I had that little statement. Okay, so of course, as always, positive and negative. I'm going to give you a little exit ticket. Sometimes these are graded, sometimes they're not. Just making sure you guys understand kind of how this year works. I would expect that you're always going to try them and do them. Why don't you just put this one on some paper of your choosing? It's something you'll turn in. So if you're using your own paper, make sure you can turn it in. Maybe tear a piece in half and give it to your neighbor. You know, if you want to do something like that. Remember, the bell schedule is a little different today, so we actually only have 5 minutes. Now, I'm sharing that because it might be that when the 5 minutes arrive that you wish you had a few more minutes. If that happens, you could turn it in tomorrow, but if you're able to turn it in today, that's always the best thing, if you're able.